So welcome to Careless Coder, and today is a very nostalgic day for me. We're going to create a program to self-play the first ever handheld computer game that I had. It's called Highway. They now have a web version created for it, and it's so addictive. And we're going to let it autoplay and hopefully get in the top 5 rankings of its high score. So this is the first ever handheld game that I owned, Highway. Now I'm pretty sure that when I owned it as an 8 or 9-year-old kid that this was burgundy instead of green. But it could be a false memory, because the burgundy were original Game & Watch games made by Nintendo, and these were clone knockoffs. So maybe that's a false memory, I don't know. I actually was looking all over online to find the real hardware, and I wanted to mod it to have a webcam over it and attaching the collector and the emitter of transistors to the buttons and then activate it and play it automatically. But I couldn't find it online to be bought anywhere. But I found this simulated game, and it is the real experience. And the coolest thing, look at that. It is also from the Netherlands. So I don't know who you are, BDR Games, but thank you very much. This is really, really cool. It's a part of my childhood. Now let's jump into the code and have some fun. So this is the code. It is based on the Qt library for C++. There are also Qt bindings for Python. Initially I figured I needed speed because I wanted to grab the whole screen and not only a part of the screen, so I figured I need C++. But as it turned out, the game's refresh rate is so slow, it's about 4 frames a second, that I could easily do that in a shitty language like Python. So this is the game logic, that is actually what controls the game based on the screenshot that is taken. And this is taking the screenshot. It is based on a little example from Qt themselves to make a screenshot. And I just took that example, threw out everything that I didn't need, and then made it. But it's really easy to create a snapshot. It's called grab window. So you have a handle to the screen and you do a grab window. So let me start this and show you how you actually select the screens, because I got 3 screens. As soon as you start the game, you put the dialog window over the screen that you want to capture and you press start. That will actually start to capture those screens. So if I move the dialog away, it will still capture this screen. Now you can save screenshots. That sometimes is helpful if you want a quick screen capture of the game, but usually I just print screen them and then find out the location, the XY location and the color of a pixel. And then you can stop the simulation. So let's run through the code quickly. So the constructor of screenshots sets up the whole dialog box. These are all the controls that are on the dialog box. This handles resizing. Now this is the game capture method, and this is the value in milliseconds of how often a screenshot is taken. So I actually want to make a little modification to the game and have an input field that allows me to select the FPS and calculate the number of milliseconds for the grab screen timer to fire. The reason is that normally when you hack a game, you will put a hack hook in the refresh. As soon as there's the vertical refresh, you would actually analyze the game settings and then issue the commands and then wait again for the vertical refresh. Since this is basically asynchronous, running freely, you need to sort of match it up with the game as you go. Now you could save the whole state and compare the states, whether they have changed, and only if they have changed you can send a key command. I did not do that. I took the quick and easy way out. I just look at the screen and say, okay, you need to move these many positions left or these many positions right. But as soon as the frame doesn't update, I keep doing that because I work faster than the game. So that's a little hack that you can actually make. Store these game states and compare them and only act when they're different. But this was easy enough because the game is so slow that I didn't figure it was worth my time. Now this is shooting the screen. So it takes the screenshot. Then I have a function called GameLogic, moved in a different file, so you can actually create your own GameLogic file for pretty much any game. Put the logic in there and then simulate playing it. It will put in the pixel map of the screen grab, and it will update the little screen in the bottom. So this one, it will update this thumbnail so you can actually watch along. And this scales the whole, capture the thumbnail that we just saw. Qt is a very, very powerful GUI library. If there's one thing you should learn and you're interested in desktop applications, Qt. Either use Qt with PyQt or C++ Qt. It's really cool. So this is the game logic. We saw that the screenshot actually calls this and puts in the QPixMap, the screen that it took the screenshot of. The first thing I do here is get a handle to X11. Now this is the only code that isn't portable. If you make this for Windows, you will need to get a window handle and send Windows messages. If you do it on Mac, well, you have to look into that. I never send anything to the Mac UI from code. But this is the only thing that is native to the game. In my case, I grab an X11 handle, I make it static so that it only grabs it once. I check if it's not null, only open it once, and then it's always set in consecutive calls. So this is my game state. Like I said before, when I run on 30 frames a second, my car shoots all the way across the screen because the screen of the game has not yet updated, and I keep on, okay, I need to move to the left, move to the left, move to the left. Those keyword events are triggered and are captured by the web browser and just sent through anyway, so the car isn't moving exactly as it should. Now I could actually have two of these structures and compare if they were different, and only if they are different continue to send the next key actions. I didn't do that because I found that lowering the frame rate was the easiest, quickest way. And I only have a day to make these videos, so I take the easy way out. Here I need to convert the pixel map into a screenshot. I make it into grayscale for the simple reason that it makes analyzing the image or the pixel a lot easier. Then I first get all the obstacles. The obstacles are the dogs. For some reason, if you hit the dog, your car is totaled and the dog is fine. I don't really get that. So get the obstacles. And this is where the logic is. I took a series of screenshots when I was playing the game, where I had the log, the little post and the dog on that position that kills the car. Then I looked for a dark pixel on the post, on the dog and on the log, and I noted where that pixel was. That is the XI coordinate based on the 1920 by 1080 screen grab that I do. So if you work on 4K, you have to change these values because they're on a different location. It's not relatively scaled. And then I check if the red pixel, because it's RGB, so I just picked one, is less than 40. And then I know, like, okay, this is a dark pixel, so that is an obstacle. and I set it to 1 corresponding the obstacle that it is. 0 is the dog, 1 is the post in the middle, and 2 is the log on the right. Then I need to get my position because I need to know whether I need to move to the left or to the right in relation to the obstacles. So I do the similar thing, get my position. Now there are 5 positions for the car. There's the starting position all the way to the right. That's also the drop-off point for the hitchhiker. And there is a position all the way to the left that you can get to when there is a hitchhiker. I ignore those positions in my avoidance algorithm, but I need to have them in case for starting I at least need the hitchhiker drop-off position or start position. And I did the same thing. I took screenshots of the positions of the car. Now as you can see that Y position is the same for everything. It's the back of the head of the driver. That's a nice big dark blob, so I can easily pick a pixel out of that. And I do the same way. I look if the red pixel is less than 40. If so, I set the position of the car to 1. And since a car can only be at 1 position at a time, only one of these indices are set to 1. So then I know the location of the car and I know the location of the objects. And then I can make an avoidance algorithm. It's a very simple fuzzy logic. And these days people are inclined to go to the AI training route. When there is a really manageable amount of inputs, don't do AI, do fuzzy logic or create, in this case, a hard-coded algorithm, which is A, faster, B, more predictable, C, it also generates a lot faster because training a neural network takes time. So avoid obstacles. Here we are. I first find in the array the position of my car. I put that in the pos variable and then I call move to safe place. First we start on the most right position. That's also the hitchhiker drop-off place, but also the position that you start with your car. And then I check if the obstacle right next to that, and that is the little log, is not set, then I'm allowed to move in that direction. Minus means moving to the left, and positive the numbers move to the right. So this says, okay, move 1 position to the right. And then it's the next frame, or the next screenshot. The next frame would mean the next frame of the game, but it is the next screenshot that we take independently. We do this again and we check if the obstacle in 0, that is the lane with the dog, then we have a bias for that. The reason for that was that I also wanted to pick up the hitchhiker, so a bias of driving to the left would make sense. So then you only need to shift to the left if you're able to pick up the hitchhiker, and then switch the bias on to the right, and then when there is a little signpost you can drop off the hitchhiker. But I already had my 8 hours spent, so here we check if the log position is 0, then we have that as a preferred position. Then if the middle of the road is 0, so that would assume that there is actually a dog on our preferred lane. Then we move to the middle of the road. And if that is set, then there is only the option of moving all the way to the right of the road. Now the game is done in such a way that there is always 1 lane available. And that's why this can play for eternity without hitting anything. And otherwise, if there is no reason, then we don't move at all, so then we return 0. So this is a really nice, clean, efficient algorithm, especially this, because I immediately tell how many places to move. If, for example, there is a dog and there is a little post in the middle of the road and I'm driving in the lane of the dog, it will say you need to move +2 positions to get to the safe lane. So that's a really efficient way of managing it. So then I know how many moves to make to the left or the right, and I need to send the keyboard commands, in this case to X11. If you would make this for Windows, you would catch a handle to that browser screen and send a key event on that. So I need to make it absolute, because now I have a negative number if I need to move to the left. But I already tell it to move to the left, so I make it absolute and send that many times the left key. And if it's larger than 0, I need to move to the right and send that many times the right key, as is in move. Now let's go to the send key. And this took me the longest to actually figure out how to do this in X11. I first need to catch a key code based on the X key sim to key code, and you need to pass in that X11 handle and the key. And the key is XK left or XK right in this case for the cursor keys. Then you send the key, but much like MIDI, and that took me a while to actually realize, you also need to send that the key is off. So you just send it and switch it off. So in effect, it's super fast. Humans can't even react that fast. And then I did that and it still wasn't working, or not working consistently. Then I found out that I needed to call the X flush X11 handle on the handle. And that would actually flush the events to the system to be immediately processed. So now let's play the game. Let's start QTES. There it is. It found the main screen, but I want to capture this screen. And let's start it. And there we go. You need to have the focus on your current window, because that is where the key presses are being sent to. And we now let it play and see what it does. It is working perfectly. It's 100% avoidance, as you can see. Now I don't pick up the hitchhikers, because if you ever seen a horror movie, be smart, don't pick up hitchhikers. So it has been playing the whole night. It lost 0 lives. So let's see where we are now. The score counter has wrapped over several times, so I'm curious. So let's kill off the cars and see what we have. So let's run into things. So let's go there. I'm the third. I should have waited just a little bit more, then I was second. I know for a fact that we can actually get there, because this algorithm is flawless. It's kind of cool. So there you have it. Third place on the highway high score list. Yeah, I can live with that. And if we had it play longer, we easily could have made second place. Now I doubt that we can actually reach first place, because the guy, Mr. Krishna, has all 9s. We probably would roll over that. So he obviously hacked the game, because the game works in intervals of 10. So I think he did some fudging there. But yeah, it's really cool. And how far we have gotten in 40 years with our games. It's unbelievable. This was really a nostalgic trip for me, playing this game again. And I played it far longer on the keyboard than I should even admit to. Yeah, it was really a nostalgic rush. So take the code, just hack it for your screen size, make it relative, do whatever you want with it, and have some fun making your own tool assistant speedruns or tool assistant game runs. So it's really nice. And especially these little LCD games on bdrgames.nl, they're really easy to make work automatically. So have a look at that, and I'll see you in the next one.